I'm Andrew. I'm from Teleport. We are a product studio that's incubated by Flashbots X. We make thought-provoking apps that are powered by TEEs, which I will tell you about in a moment. I'm also an advisor of Sentient, so louder, is that quite good? All right. I really appreciate the vision that Sentient is producing about this mission of openness as the antithesis to the direction that closed source AI is heading. I think that's extremely important. I want to convey kind of conceptually the way that I view this problem of the way the world is headed versus what we need to do about it in a kind of broad goal. I view this through the lens of losing negotiating power to large platforms and large entities. The way things are going is basically increased economies of scale that eventually create winners take all, or limited only by, say, antitrust by large state governments breaking up otherwise enormous coalitions. And what we should be doing through open source efforts, Open AGI efforts, and apps that I'll tell you about that are based on capabilities of trusted hardware is basically how to do self-assembly of groups that retain negotiating power towards the edges. This is a vision of pushing back against the natural economies of scale. And the argument that I want to make is that also trusted hardware and TEs are really the most important technology that we should be applying to this. TEs make up a portion of the OML white paper from Sentient, so the seeds for this are planted, but I want to convey a little bit more and explain what we're doing about it. I'm not going to talk directly about AI first. I'm going to talk about short-form video. This is the other mode of slop, where slop enters everyone's brains. The attention economy is, mostly spoken about in pejorative terms. It's the thing that delivers unskippable slop that you just want to keep doom scrolling through. It's very addictive and seems to lull you into just going further and further. I actually think that these are really important platforms for a bunch of reasons that show some promise, and there's some reasons to be optimistic about these. First of all, it's there. Youth love TikTok and related things, so if you want to go meet people where they are at, this is one of the ways to do that. I might put ChatGPT in this category as well, as something that's emerging, that has a ton of eyeballs to it, a ton of oversharing of personal data to it as well. So it's very important for us to take this lens of, what can we do to acknowledge the existence of these trends, but find places to push openness, given the circumstance and trained behavior that's there. There's a couple of things about TikTok that are really interesting I like to point to. The first is that, I don't know if you know that, but TikTok has a STEM button. No one knows to click on it. It's basically the learning and healthy videos feed. It's a part of TikTok. It's a pretty boring feed, so it's not as well algorithmically tuned, and it's easy to turn away from it unlike the rest of the videos. But that's where maybe hopeful educational material will be able to go in the future. And another thing is that they are, while doom scrolling is a very passive, you lose your agency as you just follow on autopilot actions, right? The user-generated content and the ability to post videos and follow creator tools to create your own content and share them with people, that's always very close at hand. So this doesn't have to be agency losing. It can be something that instills more action and intention into the world as well. To the structure of this and what this has to do with platform dominance and overtaking, right? So short-form video is fundamentally a user-generated peer-to-peer content system. You have creators and audience members who are one and the same, because you can be an audience of many people and also generate content for your friends and try to generate content and see how it can fare on the open market of attention economy there. The relationships that you have there between audience members and creators is one of a lot of feedback. Like, you do interaction through live streams, you leave comments, those influence the creators. Creators try to adapt what they do to match the expectations and needs of the audience following that they cultivate. A lot of this is quite healthy and has good potential for us to help each other improve and learn more things and get exposure beyond our filter bubbles. The biggest problem is that these are completely controlled by the platform who holds all the cards. All of these audience to creator interactions are entirely mediated by the platform. And the thing that makes them so effective is the routing. You get routed videos made by a creator that is perfect for you because the algorithm has so much detail of your behavioral patterns that it knows so much about you. It can do the routing of this information, and it essentially gives information to creators to help them, guide them to creating content that will be more appealing to you later. It's the platform that collects all of this behavioral data, so it's the platform that gets to put its finger on the algorithm and steer it in ways that keep you engaged and maybe aren't for your long-term health, but just for the continued productivity of the platform. So the design space of information apps are anything that we can make that uses the data that otherwise would only be held by platforms and instead can use it in ways that benefit the audience member and creator users as well. So this is the design space of information apps, and this is also viewed through the lens of adversarial interop. These are things that we can use AI and TEs, as I'll explain, to do without necessarily waiting for the platforms to give these to us. There's a spectrum of apps you might fit into this category of information diet apps. There's some that are just purely single player, like they might tell you how your own feed is working. There's others that are just broad population analysis, like here's analysis of trends in the rate of meme propagation through the noosphere, or through the short-form video platforms as they are. The most interesting area of apps that I'll give a couple of examples of are small groups or pairwise individuals or multiplayer apps that aren't the whole population. It's not just science about the overall world, but is about actually meaningful insights and suggestions given directly to small groups of people. So I will go over a couple of apps that I wanted to say, we haven't released these yet. I hope that these will be released on the App Store by the end of DevConnect, but not quite yet. They're called Feedling and Sync, and I'll give you an example of what these are. So these are both apps that are informed by a background processing view of your watch history on TikTok. So you link your TikTok account to a background processor. It is able to view your watch history and then reflect this watch history into apps that are useful to you. So Feedling is a virtual pet that consumes the same information diet that you consume. So when you watch videos about cats or cats receiving eye drops, those get put into like XP points attributed to the virtual pet that you have. And you get a little pop-up dynamic island notification on your iPhone app. So as you're viewing TikTok or liking videos on TikTok, they get reflected back to you in the form of this virtual pet. And this can be a shared virtual pet, so you can adopt a pet with people in your group, and so you get some feedback not just about your own watch history, but also the video watching behavior of other people you've decided to share with in that way. So it's like a different view brought to you about that surfaces maybe your behavioral patterns that you didn't know that you were exhibiting in a kind of fun way. The next one I think is maybe more interesting and gets to what you might think of using cool technology relevant to AI. So this is an app called Sync. And this is a group chat app where, same mechanism, you link your watch history into this app. This is an agentic AI app, so you essentially have an AI agent that is also there in the group chat with you. It's informed by what you say in the group chat and by the watch history that's delegated and linked in. And the idea is that it will surface interesting observations if you say your watch history reveals that you have something in common with the other people in the group chat. It will mention it. In this case, someone speaking in code that makes sense only if you realize that they were also watching the same TV show that the other people in the group were watching. So it drops a card into the group chat, revealing this insight. This is a hidden insight. You wouldn't know the insight unless you were informed by the TikTok watch history of the other person. But you don't want to share the entirety of the TikTok watch history because that would be too much. So the art of constructing an agent this way is how do you get the benefits of sharing, but only by sharing just the minimal amount that makes sense and is helpful. I won't go through more examples of this, but maybe you get the idea. The other funny ones are when it roasts you because your TikTok watch history betrays like something wrong that you were saying. Like you're saying one thing, but your TikTok you're saying you want to go to sleep early, but your TikTok watch history proves you were staying up all night, so you deserve to get roasted by a sync card in that case. So just to abstract a bit for this, and then I'll get to the technology behind how this works. The key thing that's happening here is that the platform has this view of every user's watch history and even more detailed behavior than that. As individual users, you neither have any inbuilt way to share your watch history, nor would it be a good idea to share your entire watch history. That's too much. But there's value to unlock in finding complementary or matching insights in this watch history data. And so apps that are able to make use of or surface those have a lot of potential, and we want the technology to be able to do that. Okay, so I'm going to switch to talking about trusted hardware and what role this plays and what it has to do with adversarial interop, as I mentioned as well. So TEEs are not a special kind of hardware. It's basically an execution mode that modern server processors, Xeons and AMD, and the NVIDIA GPUs also support. Compared with cryptography tech like ZK, these are kind of disappointing. Like they're not foolproof. There are physical attacks that you can do and bugs that have go through a patching cycle of these. So they're very imperfect, especially coming from the world of ZK. It's a little unsatisfying to use these. I don't advocate using these instead of ZK, but only for applications like I've shown where actually ZK on its own wouldn't be enough to do it anyway. The story isn't just that they're in processors, but also that these are confidential compute products offered by clouds. So the idea is that clouds run instances of these trusted hardware chips. The trusted hardware chips make it easier for clouds to be honest. As long as they don't go out of their way to backdoor the chips, then they're not, through ordinary uses, able to access the data with them. And the key thing, maybe I'll illustrate the key thing on this next slide. The key thing that this gives you is disintermediation for low trust developers. So essentially the trust model is you have to trust some joint combination of the cloud providers and the hardware manufacturers that produce these. But the important thing is that you don't have to trust the application developers who might be anime profile photos. Think of smart contract developers who don't themselves have a whole lot of institutional trust backing them. Instead, they're just anonymous developers who have a good idea for a new app. The basic model of TEs is you can make open source code, run this open source code on servers running in a confidential compute product from a cloud. Users who are about to decide to share their sensitive data with this app, they don't have to take the developer's word for it. They can get a signed attestation which says that this server is running in a cloud on one of these valid trusted hardware processors, and that here's the hash of the program that's running. So you can actually match this code that's running on the servers to the open source code. You don't have to take the developer's or the account owner's word for it. You get to look at the code in itself and essentially shift the trust to this product that's a joint effort by hardware manufacturers and cloud providers. That's the rough explanation of the tech stack behind this. I'll skip some other interesting papers about there's actually a lot of interesting applications that you can do if you adopt this technology and look at what it can do. I won't go into some of them now. I want to skip straight to what it looks like to use this to carry out the kind of applications that I gave examples of relative to a platform like TikTok. So the starting point is just wherever you would use a browser or a mobile OS, you instead run that browser or mobile OS in one of these confidential compute offerings. This essentially makes it safe as though it were doing local computation. You can do this computation in a remote cloud, but you know that the account owner who spooled up that server in the cloud can't be looking at or tampering with or exfiltrating the data out of it. There's no reason that running a browser in a trusted hardware has to look to the platform any different than the user's own laptop. And in fact, you can even use the IP address of the user's own laptop as where the traffic comes out from. The key thing is that the browser itself and the end of the TLS traffic, so the thing that actually checks the certificates and does the encryption, that needs to run in the confidential compute server. But where it actually comes out can come through the IP address of the user's own laptop. So there's no reason why this even has to be any distinguishable from users using their own laptops. Also, anything that the user wants to do in terms of using an agentic OS or agentic browsers controlled by AI agents, you can use that in combination with having the browser run in the TEE. You can bring that yourself or even have the agent control run on the user's own laptop, even if the logged in instance is itself in the trusted hardware. And then the last step, which I will get to a name of this, is that you can separate the process of collecting this data for the user's own use from delegating it to particular applications that you use it. So you could, for example, go through this process of delegating logging into an account in this remote trusted hardware browser. That is now your data pod that holds your data, this would be entirely open source, and as the user, you're able to choose which cloud servers it's run on. You can take the data as like a portability thing and move it wherever you need it. That's separate from the process of deciding which apps you want to connect to. You can collect the data once and choose which apps you want to delegate it to. As I mentioned this, describe it this way. This architecture that I've described of having a separate modular user-empowered trusted hardware control for logged in account data, separate from choosing which apps to do it. This is very much like OAuth and how delegation on existing internet apps works. What's different about it, though, is that it's not based on the platform choosing to allow you to do this. It's based on you building this ability into the browser that you're using directly. So we call this OAuth 3, which is a funny name because if you look for OAuth 3, there's just a page that says OAuth 3 does not exist. So it's an appropriate name for the unlicensed guerrilla version of account delegation. This is especially what this tech does. It's justifiable from first principles by satisfying these three things, that if you do all of this, then you're doing something that's actually user empowering rather than just creating the next domineering platform that locks you out of the use of your own data. So it should be portable. You should be able to decide which servers you want your data to be stored on or collected from. You should be able to understand all of this code as open source and see all of the actions that have been taken on your account, regardless of which server it's on. And the application developers should not have any raw access to your account or even the entirety of watch history. So it's essentially the same as non-custodial design that crypto projects aspire to. Like, we can't hold customers' funds. We've written some open source code, but we're not holding your keys. Same analogy here. It's just for other account types as well, not just digital assets. Everything that I've described, I mentioned that our apps are not yet released, but we follow the Ethereum process of working in the open. So you could go look at this teleport talk scope. It's a bunch of open source code that does everything that I've described in terms of how it handles accounts and can run on confidential compute offerings in the cloud. I'll also mention, but don't have a slide on this, that we also contribute to a framework called DStack, which is basically a software layer on top of the confidential compute that the clouds and processors offer. So it's kind of like a convenience layer for doing containers, makes it easier to write applications, and that's what we use for our backend with this. The last point that I will make before leaving it there for these is that, again, the phrase adversarial interrupt, this reflects the idea that platforms are based on this idea of accumulating all of the control for themselves. Everything that I've described to you is fairly subversive because it's saying we're going to use this imperfect but works, pragmatic, confidential compute technology for the purpose of bringing delegation and more sophisticated data sharing apps and privacy preserving data sharing apps with or without the platforms need to do it. A lot of the concerns that platforms have are around automation and botting and scraping, and none of the things that I've described are exactly botting. They're definitely not scraping. There's a bunch of trends that are completely separate from what we're doing or confidential compute that cause you to rethink, what it means to be the user and to express an intent. So as we have operating systems and browsers that themselves have more AI agent control, there's a very line that is getting more practically blurred now between what counts as the user's action and what counts as an agent-supported or partially AI-automated action. That's something we're going to have to contend with anyway. And really the message that I have is that, regardless of how you automate or incorporate agents into the actions that you take in browsers or OSs, the use of the confidential compute is really what's excellent is because it's able to let you get the benefits of sharing and aggregating data with other users and forming groups of users without having to share everything and without losing your ability to control the data that you share and carry out this delegation. So, okay, I will stop there. Thank you for having me. Happy to have questions. Yeah, sure. Hey.
Hi, Andrew. So you talked about TEEs and their security concerns as well. So I just wanted to understand what you think about having additional layers of security around TEs, because there have been a lot of work around in the space, breaking into TEs and physical attacks as well. So how do you think some additional layers of security would work out? for such systems?
Yeah, it's an outstanding question. So what characterizes the TEs, what we have right now, is that they are tuned for in the confidential compute cloud offerings, which I would say are even more important than just the hardware itself, although those are like a joint between the cloud providers and the hardware. These are tuned towards maximum performance and hardly any overhead relative to just plain no TE whatsoever. And what you should do to get better security is add another layer of cryptography, such as multi-party computation. Then it's not just one server, but like you've got your GCP and your AWS and Azure, and you'd have to, all three of them would have to be attacking at once to be able to do something. But that comes at a cost, being with MPC. I would say that the things that we're trying to do, being like consumer-facing applications and essentially running an entire browser inside of the TEE, are kind of well suited to that low latency, high performance, low overhead setting. The security model there is also kind of interesting. I'm not saying here we should make a new DeFi treasury that is only protected by one GCP server. If we're building apps that attach to TikTok, like the TikTok's own servers are already just in GCP. So it's kind of more well tuned to the trust model there anyway. There's a couple of trends to the future that are really important. So one is that there's this trustless TE effort by Simple Crypto. Flashbots X is coordinating it, and a bunch of other performers doing chip manufacturing are involved in this as well. But the goal is to basically make a special purpose for essentially crypto decryption, I'll get to it in a second, but to make our own trustless TEs that do not just rely on Intel and AMD saying, here they're very fast, but we won't tell you how they're secure, and we already have a poor track record for security in them. So I think that's really promising. The compromise there is making something that is now designed to be really trustless and appropriate for high security things. You're not going to beat Intel or NVIDIA in performance in that setting. But the really interesting trend that merges all of the cryptography that ZK folks are working on and this is essentially to use fully homomorphic encryption, which is computing on encrypted data, but you still need to manage the decryption key and check a zero-knowledge proof that the computing on the encrypted data was done correctly. So essentially, you would have this architecture where all the compute work is done on encrypted data using very fast accelerators that you don't have to trust at all, and just decrypting the final results would be done in this slower but special purpose, decryption and snark checking hardware. And that was a lot of more crypto buzzwords than I meant to include in my talk, but that's a path forward. That's kind of more on the research horizon as opposed to just apps you can build right now. But it's really important because it's saying that if we accept that there's things that we want to get out of this kind of programming paradigm, we're not just locked into trusting Intel and NVIDIA forever. There's some foreseeable alternative paths as well. Yeah, that's my best answer to the question. It's a very good question. Yeah.
I was wondering, with all the security issues you just mentioned, are local TEs a thing? Do they make any sense? Like, would you run something that would be trusted on like phone hardware or like someone's end user laptop? Would that like be a concept that makes sense? Like, let's say I want to trust someone's file system and then say, make sure this code was written in TE and then send it to a server somewhere. Is that a thing or no?
Yeah, absolutely. So there's some promising directions for this. What we have right now is that your phones, like any of the anti-jailbreak and like Apple Appatest or Google Play integrity, are based on trusted hardware in your phone that are designed to be resistant to physical tampering attacks, but they are really slow, and they're not general purpose compute capability. It's not the same thing as having this like just an execution mode in secure hardware. So the tension is, do you want to have more flexibility in the TE and performance, or do you want to have it more secured against physical attacks and harder to tamper with? So that's, except for this direction of like maybe you can just have the decryption keys for a more advanced FHE-based cryptography thing in there, then maybe that would work, and also those keys may as well be local. I think the most interesting thing is that the new Apple has an execution mode that is like this, but also can be on consumer devices. So I'm not as familiar with that, but it's definitely a possible direction. Yeah, and then obviously if you can do local computing, then you absolutely should. Even the thing of like delegating watch history, you can do that through a browser plugin that you run locally to merge it with other people's watch history, because there's some insights that only show up in a group. That does need a remote something. Now, it could be someone else's laptop and you're trusting it there. It's really just a question of like, do you trust that this remote server is not in someone's side channel lab and being attacked if it's out of your, so having the clouds say that not only are we running this hardware that's designed to keep us from peeking at it, but also like we're running it in our already established, supply chain security things, it would stand out for us a lot to take a racked server and put it in a side channel attack. I think that is adding a really important extra layer that makes it difficult to get the same level of security with local TEs. But definitely, I hope that's a direction that they go in. It's also kind of interesting, the history of TEs, that they started out as anti-consumer technology on laptops. Like the only original use of SGX was for Blu-ray player, like anti-stream ripping to make it more difficult to get Blu-rays out. And then it was like a sequence of failures that made the laptops themselves less secure, and then the Blu-ray didn't like the extra overhead of having to update your BIOS when a patch would be made. So it's kind of, no one liked it. And so that's why it's moved from being dropped in client laptops to now it's servers only, and now it makes more sense also. And it kind of has this quality of, before it was like putting more restrictions on end users on their general purpose devices. That's like further shackling those without much power to begin with. Now it's actually really appropriate. It's like, here's how to make servers and clouds hold themselves accountable to some, constitutional kind of thing. Like, we're not going to peek and eavesdrop on tenants' data, and that's actually a really great use for it. So that's been a shift that's taken a while to happen.
Okay, so I saw you presented this as a use case for consumers, where you have maybe like a group of people, and then it gives you more insight and creates a better collaboration within people who already know each other. But it feels like there's a lot of friction to make this happen, because you need to install a few things, or you need to watch a browser inside a browser to monitor all of this. And people usually tend to go towards less friction and easy to use applications. So is this where you think it's going to be find its product market fit, or is this just like a proof of concept?
Yeah, so this is a good question about how good the UX of this can be. I think in the general case, it also depends on how the platforms evolve in terms of making this more difficult. So what I would say is that this approach can't really be prevented by platforms, because there's really no difference between a computer running on your computer in a server, server with a TE, so it's hard to block that in general, but that is assuming that you treat it like a whole fresh computer and log in from scratch. Depending on how easy the platforms make it to do this, you can actually make the UX quite good. So this actually has a very easy onboarding interface with TikTok, especially because to sign in a browser on TikTok, you just have to scan the QR code of a fresh browser instance with your phone that's already logged in. So it actually makes it very easy to do that. You don't have to install or like look at a complicated browser or type your password again to do that. There's no guarantee that it's always that easy, depending on how the platforms decide to react to people using agents, basically. So in the worst case scenario, it is like having a whole fresh computer you have to log into and install things on. And in the best case scenario, there's no inherent reason why this needs to have any extra UX friction. All right, I think I'm good. Thank you all.